everybody. My name is Gunnar Joachim Siljedal. I am part of the organizational team here at this conference, and I'm here to introduce Professor Hubbard with the Department of Geoscience here at the University of Calgary, who will be talking about seeking the next big discovery, a retrospective look into finding evidence of the oldest hominins at Oldupai. Please take it away.
Thank you. Thanks for that. It's really a pleasure to be here today. Yeah, so thinking about what I might present today, I thought I'd go, maybe there's a bit of informality here with what I'll present. It's really a look back at our experiences at Oldupai in the 2018-2019 field seasons. And to kind of to paint the picture of where I'm coming from, I'm an experienced geologist and sedimentary geologist. However, not so much in archaeology. So this is kind of looking back at kind of my initial feeling around being part of an archaeological field team. So for those that don't know me, my background, I'm most typically thinking about things like rivers and how they work. If you saw Dr. Paul Durkin's presentation this earlier today, he and I work together on these projects, thinking about how rivers work, what controls them, the deposits they leave behind. I'm also keen on understanding the sedimentary processes that happen on the bottom of ocean basins. And on the right side, you see a map view looking down on the seafloor, some large-scale dunes that are actually being activated by bypassing turbidity currents, as you see there on the image now. So I like to use this kind of information to inform my understanding interpretations of rocks like this. These are pictures of a deep water rocks from a marine basin. They're about 80 million years old from the Andean foreland basin in southernmost Chile. So, you know, what does this all have to do with my experience at Oldupai? And that's where I bring you now. It's to just really paint that picture that, yeah, I'm experienced, but I'm fairly new in this area. And one of the things that kind of, you know, I got thinking about as I got welcome to give a presentation today is that, you know, we often end with these really slick products after a really a series of big efforts. In this case here, a paper that I was a part of here earlier in the year, led by our leader, Julio Mercader, Nature Communications, the earliest Oldupai hominins exploited unstable environments approximately 2 million years ago. Just a study I'm very proud to be part of, a lot of great people, a lot of great science. But you know, you see the glossiness, the every word is thought out, every diagram is well crafted, and you know, that's not always how science actually operates. This is just the final product, and I thought it might be enjoyable to look back at how we got to this product. And so to do that, I'll take you to Oldupai, and here you see a satellite image of the entirety of the gorge, east to west, the main gorge trending in this direction here. And of course, as a scientist interested in these larger problems, I you know, thinking about it in terms of its spatial context. One of the most important pieces of information that I needed getting going in this area is that backdrop. Where are we? Who's done the previous work? And thankfully, we had this wonderful resource put together by Richard Hay in the 1970s. This fellow did an incredible amount of work mapping and describing the geology across the entirety of this gorge. Each of these numbered sites was a geolocality where he described the rocks and painted a paleoenvironmental kind of picture based on the sediments that were present and so on. Really an impressive piece of work. And so most often folks have made the most discoveries, the longest history of working in the gorges here in the central portion of it, at the confluence between the side gorge and the main gorge. And so many of these sites, some of the famed sites were named even when Hay did his work, and he added the numbered sites to these different locations. And so this is, of course, we spent some time here in 2018. Our camp is in this map area, and we studied some of these classic sites. But toward the end of 2018, we went to the westernmost part of the gorge, as is expressed in this section here of Hay's map. And you can see there's only numbers. These are just Hay's localities, not a lot of other finds to be spoken about. Certainly when Hay did his work, and even since that time, there's been some impressive and important discoveries, but not nearly as much work done there as what we see over in the central part of that gorge. And so I wanted to kind of explain how we got to where we got to some degree. At least this is maybe at some level. At the time, I was a little bit more of an outsider. I was just learning about geoarchaeology, the bigger project, and the people involved. Obviously, as we approach that Western Gorge, thinking explicitly about that spatial context, where exactly are we going? What's been done there? That's that last map in particular. But also, of course, as a geologist, always thinking really closely about the stratigraphic context, the different layers, their ages, what kind of context do we have as we move into this this new frontier for our group. And then, of course, on top of just that background information that we're trying to understand before we dive into a new area, the getting into the discoveries from these areas, of course, things like important fossil finds. OH65, this maxilla of Homo habilis was reported on by Blumenschein et al. 2003. A real push for us to head out to this part of the gorge is to learn more about the habitat for these guys here. And of course, from older work and some more recent work, we also come to realize that the oldest stratigraphy of the gorge is exposed in the western part of the system here, or the basin, as it were. So lots of different reasons to go this direction. But the initial objective was certainly to identify and explore the stratigraphic horizon of this particular fossil, where it was found, in the locality it was found. And I'll point out it was found at the geolocality 64, which has no bearing on the name here of OH65, just coincidental in terms of the numbers being close to one another. But nonetheless, we'll try not to mix those up. All right, so with that initial objective, we need to dive into that literature. These are images from the Blumenschein et al. Paper. And so on the left, you see the location map they provided, the extent of the gorge, as I showed a little bit earlier. The Western Gorge here, they zoom in on that. And I just want to point out something here. This is a fairly large area. There's no real long information, no GPS points provided. There are some squares here, but it's not exactly sure what they are. Undoubtedly, they were maybe trench locations, that kind of thing, but we don't really know. On the right is the stratigraphic picture that was presented by Blumenschein et al. To kind of place the context for OH65. And in particular here, I point out on the y-axis is 0 to 8 meters. This is 8-meter thick column that's about 500 meters across. All right, and so their fossil find was at the bottom of a channel. Here, this sandstone channel, OH65 sits here, probably as part of a lag. And this channel is nested in the context of a series of different tuffs. So ash from volcanic events draped across this paleo landscape, which then, of course, provides us with the ability to age date and pin down the timing of, say, Homo habilis here at OH65. All right, so one of the things that we need to do is place this again within Hay, because Hay actually provided a bit more context than Blumenschein at all. Wasn't really the point of Blumenschein's paper, I suppose. In the Western Gorge, as was painted by Richard Hay, this is a cross-sectional perspective. West is off to the left here. And you can see that this stipple pattern here, it represents the basement, the metamorphic bedrock of the region. And all of the different layers, the sedimentary layers that we've been studying over the years, they lap onto the basement in this part of the basin here. And directly on top of the metamorphic basement, we have this mass flow, the Nabi ignimbrite, that is also preserved and will play an important part of our story here today. Some of the things that Hay did, he recognized and tried to recognize. There was some errors that he made. You know, there wasn't a lot of fact checking back then, but he did his best and did a really admirable job looking at correlating tuffs across the basin. Here, tuff 1A kind of separates the older from younger units within what he called here bed 1. And he also has labeled important interpretations of what he observed here, lake margin deposits, as they transition to the east into a lake basin. And this, of course, is a really important context for placing any fossil or stone tool finds, for example. All right, so with that, okay, great. We have a lot of this context and I'll show you the reality of our situation here. This is a perspective image from Google Earth. I'm looking south, so kind of turned around from the last images. You can see Naisusu. This is an Inselberg, a high point in that metamorphic basement, which is an important reference on the landscape, as is the highway here that brings us over to the west. In the foreground here at the bottom of the gorge is the Oldupai River. And some of the geolocalities of, hey, 62, 63A, 63, 64, and 65. Now, we know that in general from the Blumenschein work that they found that that Homo habilis fossil here at 64. And you'll see we emphasize maybe with a little bit of exploration, we thought there could be some opportunity here at geolocality 63, and I'll walk you through that a little bit. So the first field season, 2018, was really, this was a new area. We spent, Paul Dirk and I only spent a few days in this part of the world, and looking across the gorge, we were able to locate Geo 64, the location of the find of Blumenschein et al. And generally speaking, tie it over to a geolocality 63, where we spent a couple days measuring a stratigraphic section. And what I mean by that, this is a stratigraphic log. It's about 30 meters thick. We measured it in the location of this white line here up the outcrop. And the general scale here is on the left, these gray units would be mud and siltstone. As you go to the right, coarser grain units, gravel and sands, they dominate this far right perspective here. So this shows a general grain size profile, lithologic profile through what we observed. And we noticed a couple things right off the bat, and that was this lower section here is characterized by an overall upward fining profile. So coarser down here at the bottom and generally getting finer upward. And this is a common motif that we see in sedimentary geology. Paul Durkin talked about this actually earlier today. And the general idea is that this kind of package is really common to migrating fluvial channels. And so here's a simplified block diagram. Flow through the channel is along the axis of this blue body here. And ultimately, as the flow moves through this channel, its highest energy is at the bottom, moves the courses clasts, and up into the river itself, you lose energy, and finer grain sediments persist in the sediment in the water column. They are deposited higher up in the sequence, and therefore we end up with this really common upward fining package. This is how we rationalized what we saw here in the log. And this was important from our first pass because when you go back to the interpretation of Blumenschein et al., here's that same panel I showed earlier. He recognized that OH65 was indeed present at the bottom of a channel deposit, nestled within a series of tuffs and some claystone. Well, this is our interpretation of what we saw at location 63. Some channelized deposits, as I've indicated here in yellow. On the right are just some of the detailed rock descriptions that we made through these different dashed section lines. But ultimately, we saw a channel deposit. We saw it nested within some tuffs and some waxy claystones. We thought, all right, we have spent some time. We have found the stratigraphic horizon necessary, or that we were looking for related to Blumenschein's work. However, we had only spent a few days. And as I go through this presentation, I'll offer a few thoughts here. When putting together a study, it's really important that your results are reproducible. And this includes providing detailed location information. You'll see how that wasn't really provided in Blumenschein at all. And we struggled with that, as you'll see, which kind of changed our ideas about what we were looking at, and actually even the point of our study here. And so after field season 1, felt pretty good about what we saw here, but stand by, I'll change gears a little bit momentarily. Regardless, we were pretty excited as a group for what we saw at geolocality 63. Lots of stone tools, lots of interesting fossils. Here I am assisting Maria Soto as she kind of looks to the natural outcrops for stone tools and such. We were again found a lot of interesting pieces and said, this is where we want to go. We're going to be able to paint a better picture about the environment that Homo habilis lived in. We'll get back to this next season. And as such, a series of trenches were dug toward the end of 2018. All right, so I wanted to go back really quickly here to where I had kind of begun here with how we approached the gorge, and I have to revisit our initial objective. This is what we started with, and shortly into the 2019 field season, we realized that our objective was going to change, and this is how it got reframed. Our modified objective was to identify and characterize the oldest old one at Oldupai. So really kind of quite a different objective given where we started from. And I'll explain how we got there here in the next little bit. All right, we head back to this perspective image from Google Earth. Again, I had mentioned we knew this hill slope here was where Bloom and Shine had all extracted that OH65. We're over here at 63. That's what we do know. And one of the first goals as we went back to 2019 was to have a more firm tie between these sites, because that was something we didn't really focus on the year previous. We made some initial calls, felt pretty good about where we were, and then we had to move on just due to time. So finding Bloom and Shine's locality was tough, and as I mentioned, and so we came about it in some maybe unorthodox sort of ways. There was no information in the paper to draw from. So what did we do? Well, we got information from our Maasai team members, some of whom worked a little bit with that Bloom and Shine et al. Team back in 20, 25 years previous. And they had some ideas about where some digs had happened, and that gave us some initial clues where to look and how to maybe sleuth this problem out. And then second, midway through or partway through the field season, we were joined by Dr. Michael Petraglia. Here he is in white talking to members of our team. And for those of you that know Mike, he is a wealth of information, and there was always the expectation we'd learn a lot from him coming when he came to the area. However, we did not expect that he would have particular insight based on a vacation he had taken to the gorge a number of years earlier, in which during that vacation he stopped at the museum and hired a guide to take him to some of the major fossil sites. And one of the sites he got taken to was where OH65 was found. And Mike, with an exceptional memory, was able to help us pin down the likely location of that dig site. And so, not that Dr. Petraglia was not a likely source of all sorts of really important information, as I mentioned, but given that it came from his vacation time, insight can be drawn from the most unlikely sources, and we must adapt when we're in the field, whatever tools we can find, right? So, what does this look like then? This is a drone-based photogrammetry image. So if you saw Paul Durkin's talk today, Paul acquired this with the drone. And what we're looking at here is similar to what he showed from Dinosaur Park. To the left is the bottom of the gorge here. This is just the edge of the Oldupai River. The top of the gorge is up here on the right. It's a little fuzzy, but nonetheless, that's what the presence there is. And there's some black holes in this model. That's simply where we just didn't have the photograph coverage to make the model look any better. And so Mike, with his memory of his visit there on a vacation, this is the hill slope that is geolocality 45. Mike indicated that it was on the west side of this knoll where the digs took place. And indeed, you can see these kind of unnatural patches in the landscape, which is where we ended up believing we found the locality where OH65 was found. We identified the number of different rock layers based on where we recreated the work from Bloom and Shine et al. There, traced them across the landscape, across large gullies where things have been eroded, and over into geolocality 63, which is just coming into our view here. You can see a large part of our team working at an excavation here at this section, our kind of remote field camp here, and a number of trenches that extend up the hill slope in this part of the basin. And as I move out toward the gorge itself, you can see the Oldupai River plain here express the green rock of the Nabi ignimbrite. So this context, now we kind of know where we are stratigraphically. I told you about the channel we found last year and the important fossil finds. Well, when we put it all together, what we realized is we thought we were up here, and this is where geolocality 64 is approximately located between here 63 and 66 in this image of hay. And that's where we thought we were digging in 63. But once we did this physical correlation in the field, we realized actually we were much older. We were down here beneath Tuff 1A, which kind of changed the way we were thinking about things, not surprisingly. And so this was an important find that, again, really emphasized that mistakes will be made. In this case, they were geo mistakes. We learn from them, move on, and in this case, we might have lucked out, found something quite interesting as a result of the mistake that we did have. And I wanted to point out the next thing here is, in 2018, we only measured the top of the section at locality 63. So with one goal to try to tie in the regional stratigraphic framework of Hay to our work at 63. The next was to then measure the full section from the Nabby all the way up through the section. And in 2019, Paul and I started the field season by measuring exactly that, the bottom of the section. And so what does that look like in the field? On the right here is the locality where we had measured in 2018. And so that lower part of the section extends from the bottom of this hill slope across this largely vegetated patch down to the Nabby, which is here exposed at the edge of the river. And so when you do geological trenches, as Paul Durkin showed earlier, they're not deeply excavated unless there's some serious cover. We scrape the top away and we can get a view into the underlying rock, usually with some level of ease in general, although we do need to find that of course that in-place rock. And when Paul and I got just above the Nabby, we noticed that we got into something, some really interesting mafic sands. And so that was right on top. And in fact, these are part of an upward finding package, another one of these fluvial channel looking units. And we also stumbled upon, and Paul and I were no experts, still no experts in archaeology. We did not find this particular stone tool, but we found a few others that were at this right above the Nabby that we brought to the team and to have verified and see if this made sense, and if we were indeed finding something interesting here right above the bottom of the section above the Nabby. And so we completed our detailed observations of our stratigraphic column, tying in observations and then extrapolating them across the region, trying to understand the overall stratigraphic framework. Because what we were kind of recognizing here is we were much older than anything that's been excavated before that we knew of at the time, and we were potentially finding stone tools, but we were of course worried. There's lots of debris and we were worried about contamination. Did things just fall from the younger levels on the top of the gorge and so on? But nonetheless, the group was, I think, inspired. Julio recognized this as an important opportunity to think that we might actually be seeing a possibility for evidence for hominin activity way down here, right at the bottom of the gorge. This is again just kind of our luck in this case. I think part of any scientific endeavor in the field involves a lot of that. And so, another thought that I certainly took away from this, of course, is be on the lookout for any alternative ideas. Some of them might be even more impactful than your initial ones. Although I should say that there is now some data from the younger levels, the equivalent level to where OH65 was found from geolocality 63. It has not been worked out yet. So whether they're more impactful or not, we'll see. But this was obviously an interesting find for us. And to verify that what Paul and I were observing made sense and looked like it was intact stratigraphy, the group extended some significant pits down here right above the riverbed in what was known to be Australia, the pit down under, much lower in the stratigraphy, but ultimately became quite an important part of the story that we were able to share this past year in that Nature Communications article. So on the left, you see Paul and I's kind of reconstruction. And I say Paul and I, we led it, input from the entirety of this group that worked together. But here you see 0 to 40 meters of stratigraphic thickness on that y-axis, about 40 meters again, that x-axis. And the Nabby ignimbrite is at the bottom in this cross-sectional profile. 63.1, this is the lower part of the section this line represents, what we measured in 2019. So that's where we encountered the mafic sands with some stone tools right at the bottom of the sequence here. In this trench 7 featured some stone tools featured here on the left of this diagram on the right. And then we also recognized those original fluvial channels we thought were much younger. They're actually beneath Tuff 1A. And there was a number of different trenches dug, which yielded a host of different stone tools and mammal fossils and so on. So this sort of context that we paint, it started with the notion of really uncovering what was up here, and we were led down to this lower part of the sequence and all the way down to the bottom part of this these units that became a real focus for us as a group. And as I come to wrap up, I don't want you to read this graph on the left. I want to revisit that notion that you read the paper, very that we all put together, very polished. We show this gory details of the geochemical analysis of a number of the tuffs, and thankfully work by a number of folks, and especially Lindsay McHenry. She's fingerprinted the chemical signature of the different tufts, so we could then take samples from the field and indeed identify that, yeah, this was tuff 1A, this is tuff 1B, 1C, 1D, and so on, all within our locality 63. And all of this technical backdrop, the geochemistry, gets of course put into the paper, and it's really important evidence. But again, the real motivation for me today is to say, yeah, that's true, and it was important, it's there, but all this other stuff happened, you know, the stumbling along the way, the 2 steps forward, the 1 step back, and so on, that ultimately doesn't always get shared in the paper, but it's a real part of the learning and the exploration that happened along the way. And a thought here is that, of course, science does not always move in a straight line, despite the fact that these final products look so polished in certainty. And so with that, again, I hope I made more, like I said, a retrospective sort of me thinking back, having fun, remembering much of the work we did. And I need to acknowledge that this is the authorship of the paper, but really the crux of this big group that I was able to be part of. It's a phenomenal group of people working in all sorts of different areas to really hone in on a story that is pretty important here, I believe. And I highlight a couple names: Julio, Julian Favreau, Jonathan Umsar, an undergraduate student in geoscience who helped with a lot of the work, and of course Paul Durkin here. These are everybody contributed to the geoscience. These were the geoscience. There's a lot of geoscience discussion and advancement coming from this smaller team within this bigger one, I would say, and I appreciate their efforts. They would be de facto co-authors for sure of this kind of work. I also thank, of course, it's been wonderful to be part of the SDS team, and very thankful to Shirk for funding of this huge effort. And lastly, I have to acknowledge the input and the camaraderie of the local Maasai people. They came to work and they worked hard. They were really an inspiration on a day-to-day basis. And what I can say from this whole thing, this is most certainly the most transdisciplinary project I've ever been part of. And I think my last thought, a well-functioning, diverse team, I think without question yields the most interesting results, no matter if that line was straight or not. And with that, I really thank you all for listening, and I hopefully have time for a question or two.
Thank you so much for that animated and exciting talk. That was a lot of fun to listen to. We do have a couple of questions, and I think we might have just enough time for them. So without further ado, first one, are there theoretical or technical developments in your practice of sedimentology in the Western Hemisphere that could be applied to the East African Rift region sedimentology?
So there's more, I guess I'm reading that more in terms of just approaches and technology. Well, and I guess I look at a couple of things there that at least stood out to my mind. And if I had time, I might think of some others off the top of my head. But the drones, for example, right? Paul Durkin showed how drones have really changed the way that we can approach the rocks. When you're traveling from one hemisphere to the next, you can't be there all the time. And your field seasons are limited, and something like a drone-based model allows you to kind of revisit, which is just a wonderful advancement. And so I guess I'll choose that one as one, given the limited time here, one example. And there are, of course, many others, specifically laboratory methods and so on, that really have evolved to bring a new way of thinking about these rocks.
Right. All right, and then this one last question I think we will just have enough time for. Would you consider the geological knowledge from Hay to be dated and in need of revision? Has this Hay baggage stopped you from going in new directions?
Yeah, I think that's a great question. That you heard me really talk it up, and that's because it's phenomenal. It's a huge piece of work. It is fraught with problems, and I don't ever want to say that in a way that is demeaning in any way. There's so much work to be done there. His study needs to basically be redone with his backdrop. I mean, we've learned a lot now through dating methods and so on. We know some of his correlations are incorrect, and there's been a number of groups around the world that have already started or done a lot of work to already revise what he's done. So to say that work is the final work is definitely an overstatement. There is tremendous amount of work there to make it better, but I still give a hat to knowing how hard that work would have been done. And in the large part, he unraveled a lot of the key aspects that enable us to then go with new eyes to a lot of the areas in the gorge. So yeah, good question.
All right. And with that, I'm afraid we've run out of time. Thank you so much, Professor Hubbard. This has been excellent and very fun to listen to.
Awesome. Thanks. It's been great to be here. Take care.